This session will focus on Earth's climate history from a period of time of 1 million years ago to about 20,000 years ago. We are looking at the second panel in this project. During this period of time, Earth's climate has primarily been driven by Milankovic cycles that happened at the rate of every 100,000 years. Again, these cycles are due to the way Earth rotates around the Sun. Again, this period of time is known as an ice age, and we have ice sheets on both Antarctica and Greenland. Also, you'll notice here that generally the temperature of the Earth is running about 5 degrees below today's value, and sea level is averaging close to 80 meters below today's value. We'll start our travel forward in time from a million years ago. Notice how there are wide swings in the temperature. There's slow cooling, rapid warm-ups, slow cooling, rapid warm-ups. This continues all the way through this period. When we get to about here, you're going to see that the temperature will once again start poking above today's value by several degrees Fahrenheit. And the sea level in a couple of places will actually get close to or above today's values. But most of the time we're going to be cold and looking at low sea levels. Also, the carbon dioxide values that pertain to this period of time are above this red sneer here, and as you can see it oscillating a lot because going to oscillate basically in synchronization with the temperature and the sea level. But they're so squished together they are worthless for this chart's purposes. So we'll keep going forward in time. Again, I'm pointing out how quick the temperatures go up and then how slowly we get into a cooling cycle and it stays down, keeps going. Then these major peaks are coming at close to every 100,000 years. I think in the last million years there's been 8 or 9 cycles. Now here you'll notice the cycles get wider this way and they go taller. In other words, this is the first time in a long time that the Earth's temperature got as high as it is, and this flat top here indicates what's known as an interglacial period. That means that the glaciers have mostly melted and the Earth is somewhat warm again. When we go down in temperature, that's called a glaciation. And it's during this period of time the temperature goes up and down, up and down, up and down, up and down. As it slowly drops, and as it drops more and more water gets packed onto the ice sheets, and that's why you see sea level going down again. You'll also notice that carbon dioxide is generally following what's happening to temperature and sea level. But I'm going to emphasize again, the driving force of the changes in temperature is not carbon dioxide. It's the Earth's orbit around the Sun. And that's a big difference, because it appears that rising temperature can raise carbon dioxide or increasing carbon dioxide can raise temperatures. But neither one is in control. It's really the Earth's orbit around the Sun that's making the big difference. And here we're coming up to what's known as the last interglacial period. We are currently now in an interglacial period because it's relatively warm. 125,000 years ago we were in the same period of temperature climbing as we are today, except that as you can see temperatures were warmer by 2 or 3 degrees. Sea level was above today's value, and carbon dioxide though was basically close to the same levels we have today, even though we did that once before because of the Earth's orbit around the Sun. As we went forward in time, we once again entered advancing glaciers. Lower temperatures and lower sea levels, and at the end of this panel at around 20,000 years ago we're near glacial maximum at a point where sea levels are about 120 meters lower than today and temperature is close to 8 degrees Fahrenheit lower than it is today.